The Flash is her favorite superhero due to his incredible abilities that exceed human capabilities, which have raised scientific curiosity.
His abilities all derive from his superhuman speed that can vary from being able to run through time to being able to face solid objects and, of course, running on water.
Our interest has led us to the following question. How can we explain the conditions that allow the Flash to run on water?
That's a question of how we could explain the conditions necessary for the Flash to run on water. We need to consider the force, and to put this into perspective, an average athlete can reach an output of 0.5 kW compared to an average human's 0.2 kW. And to put this in terms that would allow us to solve for the speed that the Flash needs to run on water, we derive the formula, which is F equals CDAV squared, where C is the foot shape, which is usually 1/3, and D is the density of the water, which is usually 1.0, A, which is the area of the foot, and V, which is velocity, which is going to determine how the Flash is going to be able to run on water. When somebody is traveling at 20 meters per second, the force generated is 600 newtons, which obviously is impossible for a human, but for the Flash, would it be possible thanks to his superhuman speed? And now the speed that he needs, 1,500 meters per second, is equal to 5,400 kilometers per hour, and that's the speed of sound. If somebody's traveling at this speed, the water will not react, and the Flash will be able to run right through it, and the water will start acting like a solid, allowing him to run as if he was running on a flat land.
Because of the mathematical information that was previously shown, we know that it is more likely for a lizard like the basilisk lizard to run on water because of their minimal weight. In fact, when they hatch, they weigh up to 0.01 ounce and reach a weight of 7 ounces when they are adults. In fact, they can run for 1.5 meters per second every 4.5 meters, at which they will sink and continue swimming since then. Their movement is basically described in 3 phases: the slap, the stroke, and recovery. Their feet move vertically downward as their feet slap the water, and they move backward during the stroke. During recovery, their feet move up again, like in the starting position. The basilisk lizard is able to maintain its body above the water because of the forces generated above the water. The lizards generate force for support during the slap phase because its foot plunges straight into the water, pushing water down and away from the foot, while creating a pocket of air surrounding the foot. The Flash cannot do this, so instead he steps forward again before he breaks the surface tension of the water. The force generated by the slap is sufficient to keep the lizard's body upright and straight above the water. During the stroke phase, where they propel themselves forward by kicking their leg back through the water. Lateral reaction forces are the forces created off of the sides that allow these lizards to stay upright as they run. To create these forces, the lizards push outward during the slap phase as they fall toward their supporting limb. Then they pull toward their body during the stroke as their center of mass shifts away from the supporting limb. The effects of the lizard remain upright as long as they continue running.